In today's video, I'm going to be showing you how to use Roblox's IK controller. IK stands for Inverse Kinematics, and what this allows us to do is to dynamically move humanoids and the animation controller. So here are some examples of IK being used. So here we can see the arm being moved dynamically in real time. We can also use IK to adjust the feet animation and so that it doesn't clip through the ground. And we can use the IK controller to hold weapons like guns and to allow the hands to dynamically move to match the position of the weapon. So I'm going to be showing you two ways of using the IK controller. First way is to have the character look in the same direction as the camera. So if I rotate my camera to look to the right, we can see that my character looks to the right. If I look up to the sky, my character looks up. If I look down, my character looks down. And I can run and look to the left and run and look to the right. And another way I'm going to show you how to use the IK controller is by having a steering wheel. And we can rotate the steering wheel to the right and left. And we can see that my hands follow the steering wheel and my camera's IK controller still works. So I can steer to the right and look to the right at the same time. And steer to the left and look to the left at the same time. So to get started, I'm first going to create a base plate project. And before we even write any scripts, I'm going to first start playing the game. And while the game is running, I'm going to go into workspace. I'm going to go into my character. I'm going to go into humanoid, and I'm going to press the little plus next to my humanoid and type in IK and add a IK controller into my humanoid. And once we select the IK controller, we can see the properties of the IK controller. Now let's first talk about the chain root and the end effector. So in order to understand how the chain root and end effector works, we need to think of our character like a tree. And our character consists of motor 6Ds that are connected from one part to the next. So the trunk of the tree starts at the humanoid root part, and the humanoid root part connects to the motor 6D in the lower torso. And then from the lower torso, it branches out into 3 branches. It goes to the upper legs, and it also goes to the upper torso. And from the upper torso, it branches out 3 more times to the upper arms and to the neck. And from the upper arms, it goes down to the lower arms. And from the lower arms, it goes down to the hands. And from the upper legs, it goes to the lower legs. And from the lower legs, it goes to the feet. So now that we've visualized the humanoid like a tree, let's imagine that we set the upper torso as the chain root. And let's assume that we set the left hand as the end effector. What the IK controller is going to do is try to find a chain from the root going through all the motor 6Ds to the end effector. So it will go from the root, and it will see that it will have to go to this motor 6D, and then from here it's going to link to this motor 6D, and then from here it's going to link to the final end effector motor 6D. Now if we create a part in our game, so here's a part, this little green cube. What the IK controller is going to do, if we set this part as the target, it's going to rotate these motor 6Ds in order to try and get the end effector to this position. So let's now do this in game. So I'm going to go to chain root, I'm going to click over here, and I'm going to select the upper torso. And for the end effector, I'm going to click and then press left hand. Okay, so from the upper torso, it's going to connect to the upper arm, down to the lower arm, to the left hand. So that's going to be the chain of motor 6Ds that are going to move. Then I'm going to set the target. So for now, I'm just going to set the spawn location as the target. So now we can see that because we have the type set to transform, we can think of transform like C-frame. My end effector is going to try to match the C-frame as the spawn location. And if I walk towards, we can see that my arm is trying to get to the exact same C-frame as the spawn location. And because it goes from the root through the arms to the end effector, all these get affected. Now, if I changed the chain root from upper torso to left upper arm, like so, now we can see that the torso no longer rotates, but it starts from the upper arm down to the hand. And if I change upper arm to left lower arm, now we can see that the upper part of the arm does not rotate and only the lower and the left hand. So let me now change the chain root back to the upper torso, and let's take a look at the types. So transform tries to make the end effector match the C-frame of the target. If we change this to rotation, now all the IKControl is doing is trying to make the end effector match the rotation of the target part. And if we do position, now the end effector is trying to match the position but not the rotation. And finally we have look at, and this makes the end effector look towards the target's position. Okay, so what I'm going to do now is change type back to transform, and inside of workspace I'm going to create a part, and I'm going to anchor this part. I'm going to turn can collide, can query, can touch to off. I'm going to bring this part over here, and I'm going to change the size to 222, and I'm going to go select the IK controller, and I'm going to set this part as the target. And now what I could do is move this part to move my character's hand. Let me make this part smaller, so I'm going to go 0.5, 0.5, 0.5, and now we can see how my hand follows this part, and I can rotate this part to make my hand rotate with the part. Like so. So let's now look at the other properties. We have offset, which is a C-frame, which offsets in object space from the target part. So if I set this to a 1, we can see that we have an offset now of 1 stud from the target part. Let's change this back to 0. Then we have enabled, which allows us to turn it off and on. Then we have weight, and this determines how much of a percentage this target, the end effector is going to match the target part. So if I change this down to 0.5, we should move 50% towards the target part. If I change this back down to 0, now my hand is back at its original position, so it's pretty much like being disabled. So let's change this back to 1. Priority I'm going to be covering later on in this video. And smooth time, so if we change this to 2 seconds, and if I move the part, you can see it takes 2 seconds for the IK to respond to the movement of the target part. If we come to IKController's documentation, we can see that there are 2 properties that are hidden that we cannot see in Studio. One property is called End Effector Offset, which works a lot like offset, but offset is an offset from the target position, where end effector offset is an offset from the end effector. And the second property that is hidden is called pole. Now this pole property is kind of important, and it allows us to affect the chain's bends. So let me show you how this pole property works in Studio. So what I'm going to do now is select this part that we created, which is followed by the IK, and I'm going to duplicate it. And I'm going to move the duplicated version over here. And I'm just going to change the color so we can see the difference. And I'm also going to rename this to pole. So because we can't set the pole inside of the properties, what we're going to do is we're going to use the command bar. So I'm going to turn the command bar on. And inside of the command bar, I'm going to say workspace sup.humanoid.ikControl.pole equals workspace.pole. And this is going to set the IK controller's pole to this part over here. And now I can move this part to affect how the character bends towards the target part. And let's say I set the chain root to the upper left arm, like so. And let me move this part closer, like so. And now I can use the pole to affect the direction of the elbow. So if I want my elbows to be inwards, I can like this. I can move my elbows out, move my elbows up. Okay, so now that we've messed around with the IK controller, let's stop playing the game and let me now show you how to create the steering wheel. So to get started, the first thing I'm going to do is inside of Workspace, I'm going to create a model. And inside of this model, I'm going to create a vehicle seat. And I'm going to position this vehicle seat over here. And I'm also going to make sure to anchor the vehicle seat so it doesn't move around. The next thing I'm going to do is create a part inside of the model. And I'm going to anchor this part. And I'm going to position this part in front of the seat. So I'm going to scale this down to a size of, I guess, around 1:1. And I'm going to position it over here. Like this. And now I'm going to create another part. And this part I'm going to rename to be called handle. And I'm not going to anchor this part. I'm going to set the size to 2, 1, and 0.5. And I'm going to move this part over. Like so. And I'm also going to change this to have a different color, like this. Now, what I'm going to do is attach the handle to the part using a hinge constraint. So let's create a hinge constraint. And I'm going to create an attachment inside of the handle and an attachment inside of the part. And I'm going to select the hinge constraint. And I'm going to set attachment 0 to the attachment inside of the part. And I'm going to set attachment 1 to the attachment inside of the handle. Now, if I click on this little arrow under the play button and press run, what we can see is that the handle moves to align with the attachment inside the part. So let's fix that. So what I'm going to do is select the attachment inside of the handle, and if I can select the move tool, we can see that the attachment is in the center of this handle part. And what I'm going to do is copy the world C-frame position. So I'm going to get this, copy, and then I'm going to select the attachment that's in the part, which is over here, and I'm going to paste the position of the handle's attachment to this attachment, like this, and now we can see that the attachment that's in this part has moved to align with the attachment that's in the handle. Okay, another problem that we have is that the attachments are not rotated correctly. If I click this arrow again and press play to enter the game with my character, and if I touch the handle with my character to move it, we can see that it rotates like this instead of rotating like this. So to fix this, all we're going to do is select the attachment and change the orientation on the y-axis and rotate by 90 degrees for both attachments, like this. And if we now play the game once again, and if I touch the handle with my character, we can see that it rotates in the correct direction. The next thing I'm going to do is select the hinge constraint, and I'm going to change the actuator type to servo. And once we select servo, we should get these new properties. And for the angular speed, I'm going to have a value of 10, but you can have any value you like. And for the servo max torque, I'm going to set it to infinite. So I'm just going to type in a very long amount of 9s, and that should be converted to infinite. And now what this allows us to do, if we click run, and if we come in and find the hinge constraint, if I change the target angle, for instance -45, we can see it rotates to -45 degrees, and if I change this to 45, it goes to +45 degrees. So what I'm going to do now is create a script, and what this script is going to do is going to use the vehicle seats steer float property, and when this value changes, we can use that to update the target angle of the hinge constraint. So let's create a script, and let's delete this print over here. So the first thing we're going to do inside of this script is get a reference to the hinge constraint and the vehicle seat and store them into a variable. So to do this, I'm going to say local seat equals script.parent.vehicle seat, and I'll say local hinge constraint equals script.parent.hinge constraint. Now what I'm going to do is connect a event to the property changed of the steer float. So to do this, I'm going to say seat get property changed signal, and we're going to listen for the steer float to change, and when this value changes, it's going to call this function, and inside of this function we're simply going to use the steer float value to set the target angle of the hinge constraint. So to do this, I'm going to say hinge constraint dot target angle equals seat dot steer float. Now steer float will have a value between -1 and +1. So because this angle is in degrees, I'm going to multiply it by 45. So that means it will go from -45 degrees to +45 degrees. And if I now click on this arrow and press play, and if I go sit on the vehicle seat, and if I press left and right, we can see that the steering wheel rotates. But currently my hands are not using IK to hold onto the steering wheel. Okay, so now let's create a script in server-script service, and I'm going to name this script hold. And what this script is going to do is create 2 IK controllers for the left and right hand of characters when they get added to the game. And we're doing this on the server side so that the IK replicates to all clients. So the first thing we're going to do in this script is detect when a player gets added to the server. So to do this, I'm going to say player added connect, and I'm going to connect a function. The next thing I'm going to do is create a function called character added. So here we have a function called character added, and so when this player's character gets added, we're going to call this function. So to do this, we're going to connect the character added event to the character added function. So now inside of the character added function, let's create two IK controllers and place them into the humanoid. So let's create one for the left hand. And let's also create one for the right hand. And if we quickly take a look at the properties that we've set, we first make sure enabled is set to false, because we don't want these IK controllers to always be running. We only want them to work when they sit down in the vehicle seat. We're setting the type to transform, so it's going to match the C-frame of the target part. We're setting the chain root to the left upper arm and the right upper arm for the right IK. And for the end effector, we're setting the left hand and the right hand. And finally, we're setting the parent to the humanoid. If I now play the game, and if we go into workspace and into my character and inside of humanoid, we should now see the two IK controllers. And we can see that the properties are set except for target and enabled is equal to false. So what we're going to need to do inside of a script is detect when we sit down, and if we put attachments into the handle, so let's create another attachment, and let me name this left attachment, and let's move this attachment to the left side of the handle. What I'm going to do is get the left IK, and we're going to set the target as the left attachment, and then we're going to set enabled to true. And now we can see that my character is trying to reach for the attachment, but because the handle is far away, it can't reach. So let's move the part slightly closer. Another thing that we can do is rotate the attachment. So I can rotate it like this, and I can rotate like this to make it hold the handle correctly. So let's now stop the game, and the first thing I'm going to do is add the attachments to the handle. So I'm going to add an attachment to the handle, and I'm going to move this over here, and I'm going to call this left attachment, and I'm going to rotate this by 90 degrees, and I'm going to duplicate and move this to the other side, and I'm going to call this right attachment, and I'm also going to rotate these ever so slightly, this one to the right and this one to the left. Okay, so now let's go back into the hold script, and when the character is added, I'm going to connect a seated event to the humanoid to detect when the character sits or stands up. So over here, I'm going to say character.humanoid seated, and I'm going to connect an event. And now we're going to be using the active property, which will be set to false when the player is standing up and true when the player is about to sit down. So I'm going to say if active equals false, then, and I'm also going to add an else. So when the player is standing up, getting off of a seat, we're going to set the left and right IK enabled back to false. So we're going to disable the left and right IK, just like this. But if active is equal to true, what we're going to do is we're going to try to get the handle, so we can use find first child, and if we manage to not find the handle, we're just going to return out of this function. But if we do find the handle, we're going to set the left IK's target to the left attachment, which is this one over here, and we're going to set the right IK's target to the right attachment, which is this one over here, And then we're going to set enabled to true for both IKs. And this is the whole script finished, so everything here is finished. And one last thing I want to do before we move on is I want to move the part and handle. So I'm going to move them closer so that I can reach the handle, because remember my hands were quite far away last time and I wasn't able to reach the handle. And if we now play the game, everything should be working correctly. So while I'm not seated, the IKs are disabled, and when I sit on the vehicle seat, the IKs are enabled and the targets are set to the left and right attachment. And if I turn left and right, we can see that the IKs follow the handle. Okay, so now that we've finished the steering wheel, let's move on and make the character face the same direction in which the camera is facing. So the first thing I'm going to do, inside of replicated storage, I'm going to create a remote event, and I'm going to name this remote event to look. And then inside of starter player scripts, I'm going to create a local script. I'm also going to name this look. And inside of this script, I'm going to get a reference to the look event. So to do this, I'm going to go local event equals game replicated storage look. And then I'm going to detect when the camera changes its C frame. So to do this, I'm going to say workspace.currentCamera get property changed C frame, and we're going to connect a function to this event. And inside of this event, we're going to call the look event and pass the look vector of the camera to the server. So to do this, I'm going to say event via server, and we're going to pass the current camera's C frame look vector. So now that we're sending the event, let's create the server-sided script, and I'm also going to name this look. And this script is going to detect when this look event is fired. So to do this, I'm going to say game.replicatedStorage.look on server event, and it's going to call this function. This function is going to receive the player who called the event and the look vector that the client passed to us in the event. And in here, all we're going to do is simply print the look vector for now. And let's now play the game and see if it works. So if we look at the output, we can see that these events have been sent. And if I rotate the camera, we can see that the events get sent. And we can see that quite a lot of events get sent. So if we go into View and Network and look at the overall outgoing, we can see by default we send around 0.2 kilobytes a second. But if I start rotating the camera and we look at the overall output, we can see it increases to 1.8-ish. So let's try to optimize how often we send the camera's look vector in order to optimize how much data needs to be sent from the client to the server. So the first optimization we can make is, instead of sending the look vector every time the C frame changes, is we can measure the angle between the last time we sent the event to the current look vector. And if the angle is a certain amount, then send the event, so that we don't send the event for very small increments. So to do this, the first thing I'm going to do is create a variable called look vector. And by default, I'm going to set it to vector 0. Now let's use the dot product to work out if the camera has rotated enough to send the event. So at the top of this function, I'm going to say if workspace current camera cframe.lookVector, and I'm going to use dot look vector, which is this vector here, is greater than 0.999, then return. You may be confused to why I'm checking if the dot product is greater than 0.99. So let me quickly explain how the dot product is going to return values. So if we assume that we have two look vectors looking north, so here's our two look vectors, And if we did a dot product on these two vectors, this would return a value of 1. And if we had two look vectors, one looking to the north and one looking towards east, so there's a 90-degree angle between these two look vectors, this will return a value of 0. And if we have a look vector looking north and a look vector looking south, so there's a 180-degree angle between these two look vectors, this will return a value of -1. So what we can see here is if the look vector that we saved in this variable and the camera's look vector is greater than 0.99, that means that the two look vectors are very close to one another, because remember, if the two look vectors are the same, it's going to return a value of 1, and as the angle increases from 1, it's going to decrease all the way down to -1. So as long as it's higher than 0.99, we know that the two look vectors are close to each other, and we're not going to send the event, and we're just going to return out of this function. Another thing you may be confused about is when we initially start this script, the look vector is set to 0. And if we have a look vector pointing towards the north, so let's say the camera is pointing north, and the script's look vector is initially set to 0, so it's not pointing in any direction, this will always return the dot product of 0. So it's just like having two vectors that are 90 degrees apart from one another. So if the dot product of these two look vectors have become less than 0.99, what we're going to do now is we're going to update the look vector with the camera's latest look vector, and then we're going to send this look vector to the server. So let's now play the game. And we should see that as soon as we log in, the camera's look vector gets sent. And if I start rotating, we see that unlike before, where it used to send many events, now it only sends events once I've rotated a certain amount. And what I can do is reduce this 0.99. Let's say I reduce it to 0.5 and play the game again. And now I need to rotate my camera even more before the event is sent. And one thing we need to make sure is that we do not go lower than 0, because if we go into a value of -0.1, now the initial look vector will be 0 and we will never be able to pass this return. So make sure the look vector, the minimum you can go to is a value of 0, and this will make sure that the event is sent every time we rotate the camera at least 90 degrees. So I'm looking forward to the north, and once I rotate 90 degrees, now the next event is sent. So pick a number here that represents how much data you want to save, but I feel like 0.99 is a good number. And let's now move on to the next optimization that we can make. So if we look at the network overall outgoing, we can see it's around 0.2 when we're not moving the camera. And if I move the camera slowly, we can see it goes up to around 0.4. But if I start moving my camera very quickly, we can see that it's still, even though we have the optimization, goes up to around 2 kilobytes a second. So currently we're only checking the angle and only sending an event if the angle changes by a certain amount, but let's also add time. So let's only send the event if a certain amount of time has passed since we sent the previous event. So to do this, at the very top, I'm going to create a new variable and I'll call it event time. And by default, I'm going to set it to -mathhuge. So after we've checked the dot product to make sure the camera has rotated so much, let's now get the delta time since the event time and the current time. So to do this, I'm going to say local delta time equals time negative event time. And now I'm going to say if delta time is greater than 0.1, so at least 0.1 seconds have passed since the previous event, then I'm going to update the look vector and send the event. I'm also going to update the event time. So let's set the event time. So this code that we've currently written will reduce the amount of data being sent to the server, but there are a few little problems, but let's ignore that for now and let's just test it. But to make it a bit more obvious, instead of only waiting 0.1 second, let's wait 0.5 seconds before sending the next event, and let's press play. So we can see that if I rotate the camera slowly, the look vector is being sent to the server. And if I rotate very quickly, then there is a delay of half a second before the next event is sent. And if we look at the outgoing kilobytes a second, we can see if I'm not moving the camera, it's around 0.2. And if I start moving the camera very quickly, it increases to around 0.26. So let's now talk about the small logical problem with this script. So let's assume that the camera is facing north, and then the client rotates their camera to face northeast. Now, because the camera has changed, this event is going to be sent to the server. So to indicate this, I'm going to put a green circle around this event. And then after this event was sent, the client continues to rotate their camera to face east. Now, because the time it took from this event to rotate to look towards the east was less than 0.5, this direction was never sent to the server. So the server still believes that the client is facing northeast, where in fact it's really facing east. So that's the problem we have with this script. So to fix this problem, what we're going to need to do is if the delta time is greater than 0.5, we just instantly send the event. But if delta time is less than 0.5, we're going to need to schedule for an event to take place in the future once the delta time has reached 0.5 seconds. So to do this, I'm going to create a new variable and I'm going to call it schedule event, and I'm going to set it to false. And now if delta time is less or equal to 0.5, so I'm going to add a else, I'm going to say schedule event equals true. And then I'm going to add a task wait, and we're going to wait for 0.5 negative delta time. And once we've waited for this delay, we're going to send an event to the server. But the only difference is we're going to set scheduled event back to false once we've waited. And then finally, if an event is scheduled, we're going to ignore any C-frame changes. So what I'm going to do here is say if scheduled event equals true, then return. So you could think of scheduled event being a debounce, and once we schedule event, we set it true, we wait the amount of time that we need to wait for the next event to be sent, then we set scheduled event back to false, we update the event time, update the look vector, and send the look vector to the server. So let's now test our code to make sure it's working, but one change I'm going to make before we play the game is I'm going to set the event delta time from 0.5 to 5, and that should make it very easy for us to test to make sure this new code is working. And then I'm going to press play. When we first enter the game, we should see two events, one of the camera angle before the character is spawned and one of the camera angle after the character has spawned. So we can see our two events. And now if I move, we can see we get another event, and if I move again, it will wait 5 seconds before the next event is sent. Now, one way we can test to make sure that our new code is working, what I will do is move the camera by a very small amount. We should get an event, and then I'm going to quickly move the camera by a large amount and wait and stop moving the camera. And we should see that even though I've stopped moving the camera, the next event should be sent after 5 seconds. So the server should have the latest direction of the camera. So move a small amount, move a lot, stop. And now, after a small delay of 5 seconds, now we can see that the server has the latest camera angle. So now that we've completed this script, let's change this 5 back to a more reasonable number. So I like a number of 0.1 seconds, but you can pick any number you like. And remember that the higher this number, the less amount of data we will be sending to the server. Let's now go to the server's look script. And instead of printing the look vector, let's set the look vector as an attribute to the player's object. So to do this, I'm going to say player set attribute look vector, and I'm going to use the look vector. And we don't have to set this as a unit, but this is going to prevent exploiters from passing a very large look vector. Another thing I'm going to do is when the player enters the server, I'm going to set the look vector, and that way we can always rely that there is a look vector set on the player, and that way we don't have to do extra checks. So what I'm going to say is game.players player added, and I'm going to connect a function, and to this new player that gets added to the server, I'm going to set the look vector to vector 0. If I now play the game, and if we look inside of players, and if I select my player and scroll down to the attributes, we can see there is an attribute called look vector, and it has a vector free set. And as I rotate my camera, we can see that the look vector gets updated. We can also see that our optimizations are working. So we can see that our kilobytes a second go to around 0.4 to 0.5 if we move the camera very quickly. And if we move the camera slowly, we can see that we have a kilobytes of around 30 to 40. So now that the server is setting the look vector attribute, let's create a new script, and this script is going to use each player's look vector to make their character look in the direction of the look vector. So inside of starter player scripts, I'm going to create a brand new script, and I'm going to call this script character IKs. Inside of this script, I'm going to create a function called player added. And when we first enter the server, we're going to loop through every player on the server and call the player added function for that player. So for player in game players get players, and we're going to call the player added function for that player. Now, after we've entered the server, new players may enter. So we need to also connect an event to the player added event. So to do this, we're going to say game.players player added connect, and we're going to connect the same function, this player added function, to this event. Okay, so now that we know when a player is added to the server, I also want to know when a player is removed from the server. So let's create a brand new function called player removing, and let's connect an event to the player removing event and call the player removing function when the player removing event is called. And the reason why we want to know when a player is added and removed is because when a player is added, I want to create a part for that player, and when a player is removed, I want to destroy that part for that player. So to do this, at the top, I'm going to create a variable, a table called parts, and inside of here, when the player is added, I'm going to create a part. So I'm going to say part equals instance.new part. I'm going to anchor the part and set part can collide to false, part can query to false, part can touch to false. I'm also going to make the part transparent so we can't see it. And I'm also going to set the part's parent to the workspace. Now for now, because I want to see the part, I'm going to comment out the transparency property. And then I'm going to add this part to the parts table. So to do this, I'm going to say parts, and I'm going to use the player as the key for the table, and I'm going to set the value to the part. And then when a player is removed, I want to destroy this part. So to do this, I'm going to say parts, and I'm going to use the player as a key, the same way I did here, and I'm going to call the destroy function. And finally, I'm going to set the table with the player as the key to nil. Let's now use the run service to update the position of these parts. So at the very top, I'm going to get the run service, and then I'm going to connect a function to the render step. And inside of this function, I'm going to loop every part inside of the parts table. So to do this, I'm going to say for player, part in parts, do. And remember, we use the player as the key, so that's why the index is the player. And inside of this loop, I'm going to make sure that the player's character exists. So to do this, I'm going to say if player.character equals nil, then continue. And then I'm going to update the position of the part. So to do this, I'm going to say part.position, and I'm going to position it at the head position of the character. And then I'm going to use the look vector that the server sets, and I'm going to multiply this look vector by 10 studs. So if we now play the game to test the script, and we should see there is a part there floating in front of my head. And if I move my character, we can see it moves along with my head. And if I look inside of the players and select my player and scroll down to attributes, as the look vector gets updated, so does the position of the part. So I can rotate my camera to update the look vector, and the part will move along with my camera angle. And because we've created this part in a local script, if we go and look from the perspective of the server, we can see that there is no part and the part does not exist for the server. Okay, so now let's set up the character's IK. So the first thing we're going to need to do is detect when a character is added. So I'm going to add a new function called character added, and this is going to be called when a player's character is added. So down here, after I've set the part to the table, I'm going to say if player.character is not equal to nil, I'm going to call the character added function and pass in the character. Because remember that the player may already be on the server when we first enter the game, and they may already have a character. So we want to make sure that we set up this character as soon as we enter the game. But in the future, if they get a new character, we also want to connect an event to the character added event. And when this event fires, we want to call the character added function. So when the character added function is called, let's create the IKController. So I'm going to say IK equals instance.new IKControl. And then I'm going to set the type to look at. I'm going to set the chain root to the upper torso. I'm going to set the end effector to the head. And then I'm going to get the part from the parts table using the get player from character function to get the player key. And I'm going to set this as the target. I'm going to set the weight to 0.999, and I'll explain this later on in the game. And finally, I'm going to set the IK's parent to the humanoid. At the current time of making this video, the IKController has a few bugs. One bug is when we attach this IKController to the humanoid and we use the head will sometimes, at very rare cases, float. And to stop this from happening, all we need to do is add a task weight at the top of the character added function. Another problem of the IKController, for the neck joint, when it breaks when the character dies, it will crash the game. So a way we can fix this is we can wait for the character to die and destroy the IKController. So to do this, I'm going to say character.humanoid died, and we're going to wait for it to die. and when it does die, we're going to destroy the IK controller. In the future, once the IK controller bugs have been fixed, you're going to most likely want to remove this line of code. So to make sure that we remember to remove it once the bug has been fixed, I'm going to make a comment saying temp fix. So this is a temporary fix, and once the bug has been fixed, you're going to remove this line of code. So now that we've set up the IK controller, let's play the game and see if it works. So we should see that when I rotate the camera, the part moves and the character looks towards the part. So if I look up, down, the character would look in any direction I set the part. Now, one thing you may notice is that the part moves kind of slowly, and this is because of the optimizations, but it's possible to move the part smoothly locally. So we could set the player's look vector attribute locally and update it more frequently to give a more smoother experience for the local player. So let's go back to the local look script inside of starter player scripts. And at the top of this function, when the C frame of the camera changes, let's set the attribute to the most recent look vector of the current camera. So to do this, I'm going to say game.players.localPlayer, set attribute. I'm going to set the look vector attribute, and we're going to set it to the camera's look vector. And because we're setting this attribute in a local script, this attribute will not replicate to the server and to the other clients. So let's go to test, and let's start a local server with 2 players. So you should now see that we have 2 players in the game, and if I rotate the camera for the player on the left side, we should notice that the part moves very smoothly for the player on the left, but doesn't move so smoothly for the player on the right, because the player on the left is updating the look vector attribute locally, while the event is only being sent to the server optimized for low data usage. So the part should not move as often for this player. So let's move the part up. We can see for the player on the left, it moves very smoothly, but for the player on the right, it doesn't move very smoothly. And if I move all the way to the left, you can see my character looks to the left and my character looks to the right for both players. But the player on the left, it's smooth, but the player on the right, it's not so smooth. And the same is true for the other way around. If this player moves their camera, it's smooth for them, but not so smooth for other players. Okay, let's go back to the character IK script, and let me explain why I set the weight to 0.999. If we play the game, and if I go into workspace and open my character and open my humanoid and find the IK controller that controls the head, which is this one here. Now we can see the weight is currently set to 0.999, and if I look all the way back to behind me, we can see that my character gives up and then starts to look forward. So it only looks to a certain range, and then once it gets too far, it gives up and starts looking forward. Now if I set weight to 1, now the character never gives up and always tries its best to look at the part. And so you can see as I rotate, it starts to do these weird movements that you may not like. So to stop this, an easy fix is to simply set this to 0.999, and now if the part goes too far back, the character gives up and starts to look forward and then rotates like this. Okay, let's now talk about priority. So IKs have a property called priority. So let's find our IKs. And we can see priority is set to 0 for all 3 of our IKs. And if I sit on the car seat and if I rotate my head, we can see that it affects the hands of the character. So we can see that my hands go through and no longer hold onto the steering wheel. And the reason for this is if the hands move first and then the upper torso moves second, it's going to affect the placement of the hands. So we need to make sure that the torso moves first and the hands move second. So what I can do is find the two controllers that move the hands, which is these two at the bottom, and I'm going to set their priority to 1. So now we can see that even when I rotate the torso, because the hands rotate second after the torso, now they are placed correctly on the steering wheel. So let's make this change permanent. So let's go back to the server script service hold script. And here when we create the IK for the left and right hand, what I'm going to do is set the priority to 1. So I'm going to say IK left dot priority equals 1, and the same for IK right. So IK right dot priority equals 1. And also finally, we no longer need to see the part that the character looks at. So we can set this to a transparency of 1. And now we've finished all our scripts. So now that we've completed everything, let's quickly overlook the entire project. Inside of Workspace, we have a model, and inside of this model, we have a vehicle seat with a part called handle. And this handle has an attachment called left attachment and right attachment. And we have a script, and all this script does is detects when the steer float changes for the seat, which is this property down here, steer float, and when it changes we update the hinge's target angle, which is this property down here. Next we have a script called hold, which is inside of server script service, and what this script does, it detects when a player is added to the server and also detects when a character is added to that player. And when a character is added, we call this function, which creates 2 IKs, one for the left hand and one for the right hand. And then we detect when the humanoid of the character sits or gets up. If the humanoid gets up from a seat, we disable the left and right IK controllers, but if they sit down, we try to find the handle inside of the model. And if the handle is found, we set the left and right IKs target to the 2 attachments inside of the handle, these 2 attachments here. And finally, we turn the IKs on. We set enable to true. And in order to make the character look in the same direction as the camera, we have a script called look inside of starter player scripts. And what this script does is it detects when the camera moves, and we efficiently send the look vector to the server. We also set the look vector locally for the current player in order to have a smooth movement for the local player, but efficient movement for other clients. Then the server receives this event and sets the look vector attribute so that everyone in the game knows what direction that character is looking in. And finally, we have a character's IK script, and this script detects when a player joins the server and also creates a part for each player when they join the server and destroys the part when they leave the server. We also detect when the player's character is added to the server, and when the player's character is added, this function is called, and we create a IK controller for that character. And finally, we have a run service which loops through every part that is created here, which we add to the parts table, and every part position is updated based on the look vector attribute for that player. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.